So hello guys, welcome to my next video. Today we will cover face recognition topic by using FaceNet and MTCNN models. Let's create Google Colab. So face recognition, we will cover this face recognition topic into two videos. So this video is part one. So in part one we will create model, and the model will classify human faces within the labels, whether this face is belongs to me or belongs to another man and other people. And in part two we will talk the same concept but in real time. So let's rename it main. So first of all, we should connect this Google Colab to my drive. So let's connect. So in order to connect, we should run this cell. So let me to make it much more bigger. 28, I guess, is good. So let's run again. Connect. So I'm connecting it. Yes. Hello. So okay, we connected Drive to this Google Colab. So first of all, we should install MTCNN model. Install MTCNN. So in my drive, if we go to face recognition folder, in dataset, I have four humans. So Taylor Swift, me, Robert Downey, and Jenna. So let's select one image, copy paste. Then now I will take that image and I will show you how MTCNN works and how we will use MTCNN manually. And then we will create class which will do all these things automatically. So before diving into the coding, so first we need to import all necessary libraries. So first of all, import CV2 as CV, import OS, import TensorFlow as TF. Then we will import matplotlib, import matplotlib by plot SPLC, and we will set os.environ and tf cpp min log level. Let me do like this, level equal to 2. Okay, matplotlib, no matplotlib by plot. Here should be by plot. So here it is. So we will read image by using cv.imRead function. We will give the location of file, and as CV as OpenCV read images as GBR, BGR as BGR format, channel format, and PLT matplotlib reads images as RGB channel format. So here we read this image, right? If I want to visualize it in the matplotlib, it will be a little bit different image. For example, im show image. So if we do like this, okay, we should run this cell. So here, as you can see, this is that it reads our RGB image. It reads RGB, but our image is BGR. So we will convert it. So in order to convert it, we will use cv function cv.cvt if I don't mistake, yes, cvt.color, and we will give the image, and we will give cv.color from BGR to RGB. We will convert it and we will show it. So here's now the real image. If you look to background, the image initially is this kind of background, has that kind of background. If we, for example, if we choose maybe image 9 maybe, right? No, let's choose image 5. In image 5, so here is the image in RGB channel format. So now we read image, right? We import image. Now we should implement the MTCNN model in order to extract only face, only my face as boundary box. So we will use MTCNN. So from MTCNN import MTCNN, it should be MTCNN, right? So detector equal to MTCNN, and so this detector also receives a RGB file. So our image is already converted to RGB channel format. So now we will give this image to this model. So results equal to detector dot detect image, detect faces, and we will give our image. Here's TensorFlow is running as a back end of this model. So if we go to results, results will show us many things. First of all, boundary boxes, then confidence level and other things. But we only need this box, the corners of face. So we will do next. What we will do next is that we will define the boundary box from these results. We will get them. So x, y, width, height will be results. So here you can see there's only one face, so only one output. In one list, there's one output. So results.0, and then we will need only box. So yeah, here it is. So now we will draw rectangle in this image. In order to draw, we will use CV. CV is perfect. CV dot rectangle. So in order to draw rectangle, we will give the image. So it is image. Then the first corner will be x and y, and second corner will be x plus width and y plus height. And then we will give color. I will give blue color. So this is also RGB. I mean that this is represent for red color, this represents for green color, this represents for blue color. So red and green is 0. There's no, it will not mix them. It will show only pure black, dark blue. So then the last one is thickness. So we will give as 30. I think 30 is enough. Then we will use plt.imshow and img. So here it is. So the model MTCNN detects my face. Here's boundary. So next step is that we will take from this image only that face, that position, that box. So we will use image, and we will give y till y plus height, and then x till x plus width. I think it should work. So my face will be this one, and let's show it. plt.show my face. So okay, I'm doing some mistakes here. So if I don't, I think here's a mistake, maybe. Okay, maybe here is, no, why it's not showing? It should show. Oh, okay, plt.imshow. So only my face, and it's blue. So here it is. But the next step is that we should resize it, because FaceNet takes as input 160 to 160 to 160 size of image. So we will use another CV function, cv.resize, very common, very kind of simple structure. So again, my face, then we will give target size 160 to 160, and it will show at that position. Here it is, 160 to 160, 160, 160. So we have done all of these things. So my face, here is the array, and what we need now, what we are looking for now, is that we should automate all of these things. I am doing it by myself, taking that image, changing its channel type, giving to MTCNN, and resizing it and taking that. So I should do this, and I should do this all of this thing automated. So let's create a class. Let's close it. So part 2, automate the pre-processing. So let's create a class. So face loading. So we will create a function, def init. So we will give self, we will give directory. So what I want from this class is that I will give only the path to directory. And this class should automatically detect labels and put all images into X array and all the labels into Y array. So as output, I should receive from this class X and Y to train the model. The def init self directory, so self directory equal to directory, and then self dot target size equal to 160 to 160. Self dot x equal to empty array. Let's make it first of all. Well, self dot y is equal to also empty array. So now we'll create another function. Let's do extract face function. Extract face. So it will receive only a file name, and based on file name, it will extract, give us image array. So we will use okay, image will be cv.imageRead file name. So we will convert this image to cv.cvt color image, and then cv.color blue green red to red blue red green blue, and then what we did, so convert it, and then we will take results. So we will use this one, the results equal to detector. Maybe it's better to make self.detector and give here the detector MTCNN again. Maybe it's better. So here I will give results. Let's make it a little bit small, maybe less, xy width height, and we will assume that in one image there is one face only, and we will take box. So then we will extract, no, before doing that we will do another important thing, is that xy will be equal to absolute of x and absolute of y for debugging purposes. Then we will extract only that part. So face will be then image y to y plus height, and then x plus width. It's only face array. So after that we will resize this face array, then cv.resize, we will give face and self.target size. Then it will return that face array. So first function is done. So let's create another function. So def load faces. So it will receive directory. Right. So this load faces, so what it will do is that it will receive only a directory, and based on that directory, it will create x and y. So that for x it will call extract face function. For y it will wait, just duplicate the name of that class. So here faces equal to empty list. Then for image name in os.dir list dir, then we will give directory. So the path will be directory plus image name, and then single face will be self.extract face. We will give this path. So it will return the face array for single face. So what then we will do is take that one and append to faces. Faces.append single face. So it's better to do it with try and accept. Oh, accept exception se pass, then return faces. So yes, then the last function, it will be load classes. I know maybe names of functions a little bit complicated or a little bit messy, but that's what I came up. So then we will check each subdirectory from the directory for classes in the directory. So we will create for subdirectory in os.listdir. We will give self.directory. So for each subdirectory, we will, so let's make a path. So path will be self.directory plus subdir directory plus this one plus subdirectory plus another slash. Here's a path. So we will give this path to load faces. So faces equal to self.load faces. So we are giving this function here, and we will give as a directory this subdirectory, subpath. So for example, subclass here is Sardor. This is subclass, this is subclass, this is subclass. So then faces. And then we will take faces from here, and beside, at the same time, after receiving the faces, we will create labels. It is sub directory name for any in range len faces. So for each subdirectory there is labels, and then let's create print function, print loaded successfully. Then we will give the names of labels, it's better. So then we will give assign these faces to x self.x extend. We will use extend. It's much more. Anyway, it doesn't matter even. Self.y.extend labels. So for each subdirectory, it will run. So for each subdirectory here, we will take faces and its labels and save to x and y, which is here. And then at the end, we will return this self.x as numpy, np.array, np.sArray, and then np.sArray for self.y. So here it is. So what it's saying, okay, I see. It says that there's a problem. Labels, function, labels, it is. So it's done. Then we will call this function. So then we will call, no, before calling, let's create another function. It will be also useful. F.plot images. So it will use self and limit. Actually, we don't need limit. It's not necessary even. So here, number of columns, we will do assign 3. Number of rows will be based on length of self.y divided by columns. So we have columns, we have rows, and so we can create subclass, subplot. So plt.subplot. So subplot and rows and columns and index, right? So we will create function for image in self.x. Let's okay. Number image in self enumerate. We will use enumerate then. It's also okay. Enumerate index plus here num plus 1 subplot, and we will plt.im will show the image. Plt.im show, we will give the image, and we will turn off the access to show the image clearly. So this function should also help. So let's see if any mistakes or errors occurs. So then face loading is our class. Let's push tab. So here's face loading. We will give directory. Let's copy this directory. Copy paste. We will give the directory and face loading dot load classes. So if we use this, it will give us as a return 2 things. So let's define them, x and y equal to them. So now it's running. So here's TensorFlow running as a backend of MTCNN. So in images, if we look to images, just wait. So if we to look images, so here is images for Robert Downey. Here's images for me. So here is images for Taylor Swift. And I use Jenna because she's now trendy, mainly because of that. So here's its training. Then we will use this function to show the images, plot images. Okay, our print is working. Yeah, I know it's taking a lot of time. In R2, we will use another model. We will use Cascade face detection model. It works very fast. But this model works accurately, much more accurately. So face loading dot plot images. We will give like this. It should okay, plot images, face loading images, so it will show the images. Okay, yeah, I agree. It takes a lot of time. I think now it's done. It's almost done. Okay, NP is not defined. Oh. I thought that I import numpy. Oh, I forgot about numpy. Import numpy as NP. So let's try it again. So here it is. Let's go. It will show the images. Means that we automated all the things. It will prove that. So now it will be the part with FaceNet. So we will save these outputs from our class for future users. So np dot, we will use np dot, how it was, np dot For don't mistake, it was np.saves compressed. So we will use this after FaceNet. Okay, we will implement FaceNet. So before implementing FaceNet, let's import FaceNet. FaceNet pip install FaceNet keras FaceNet keras FaceNet. So it will import FaceNet. Then we will use from keras FaceNet import FaceNet. Okay, it's done. Okay, it's showing mistakes. Now must be 1, not 40. Okay, it says that there is a mistake. It's making it's telling like that, but we will do +1 to decrease that because it is limited. Because it only takes the integer. Maybe it's like, I think you understand, right? If I take, if this length is, for example, 7, and if number of columns 3, it will give as a 2, but there is one image left here. So I will assume like, okay, we'll give one more extra. So if you do like this, then it shouldn't do, okay, not 40 again. Number. Maybe it's better to give 2, maybe. I don't know why it's having the problem. Add figure, subplot, number of columns, number. So, okay, anyway, here's images. Okay, it's not clear. I should fix it. I should fix the size. So plt.figure. We will give 16 to 12. Maybe it will work. The number of columns 3. It's 40. 40 divided by 3. It will be 13. 13 plus 1. 14. 13 multiplied to 3. 39. 31 plus 1. 40. So 13, 14, 14, 3, 3. It should work plus 1. It should work. I see. I guess I should rerun this part. I should declare it again back, but I'm not sure whether this will work or not. So anyway, let's do this running next time, but now we will use our own function. So not self x, we will just give the x here. And let's see. Okay, plt figure not tuple x size equal to, okay, very self. Okay. Now it's better, right? So here's images, all of that images. Let me declare the thing in the class. Here, fixed size, figure size, 16 to 12 is enough. Okay, maybe 18 to 16. Maybe it's much more better. Okay, here's it. So all images, only faces. So our class is working great. So it takes images and it converts to, okay, it converts, right? Yeah, it converts to 16 to 16, and then it put all of that things into X list and into Y with names respectively. So here we will do part 3, FaceNet. So we will install FaceNet. It's better to install FaceNet rather than downloading from GitHub, because I downloaded from GitHub too, but when I downloaded and loaded model, there was not matching with requirements of the model. So there's a big problem, big headache. So it's better to load from this library. So keras FaceNet import FaceNet. So then we will create another function. So yeah, we will create functions because functions are better. Makes life much more easier. FaceNet. So we will declare that. So def get embedding. So we will give the image, face image, and what it will do is that it will take the face image and it will convert the face image type to floats 32, and then we will take that image. We will add another dimension. So face image will be np.expand dimension of what? Face image, and x is equal to 0, because TensorFlow requires 4-dimensional. In our case, this FaceNet face image is 3-dimensional. So it's 160 to 160 to 3 channels. But we need 4D image. So it should be, first one is doesn't matter. None, maybe none, maybe 1, and 160, 160, and 3. It asks from us to have this kind of dimension. Okay, then we will give this image to the model. Then y hat equal to embedder dot embeddings. We will take face image and we will return the y hat, only the 0, only the first one. We are assuming in all of these things that one image has only one picture, only one human face, I mean. So here the function is ready. Yes, and now we will create one for loop in order to put all of these images into the FaceNet. So embedded x equal to empty list. So for image in x, we will put get embedding. We'll call this function and give the image, and as return we will receive the one-dimensional. No, actually we will receive 512 dimensional image. So we will receive one dimensional to one dimensional, and finally 512 dimensional image. So very interesting, very powerful. The model behind how the model. If you're interested about how FaceNet works, I also looked to backend how this FaceNet works. It consists of many convolution layers, and at the end it gives us this 512 dimensional image. It's a unique image, and every human has their unique, and every face will have this kind of unique image. This is 512 dimensional array, and basically what we will do next is that we will compare these arrays to each other, which is similar, which is not similar to each other. That's all. So very, very powerful. So we will take this one. So what we will do is that we will append embedded x dot append this output, and then we will convert this list to numpy equal to np dot array. So we will convert to arrays. So what it's saying, so model numpy expand dimension, expand, so maybe expand dimensions like this. Okay, it's working, it's training. So actually FaceNet working pretty fast. It's done. So now we will save this x, embedded x and y. Future users it will help. It will definitely help in part 2. So we will use np.savez compressed function. So we will give the name faces embeddings done for classes dot npz, and we will give the embedded x and y. So here it is. So it should appear here. No, it's appeared in it appeared here. It's here now. So now last part, we will create simple SVM model to compare each these arrays, 512 dimensional arrays, to each other, and then we will see how they are working. So we will save it for future use. Now let's import train test split. So sklearn from sklearn.model selection, import train test split. So x train, x train, y train, from first x train, then x test, and y train, then y test. So we will call this function train test split, and we will give embedded x and y. We will do shuffle. We have to do that, and random state, just in case. Why I'm talking about making shuffle is true, because if you call this y, you can see first all of them is Robert, then it's all of them it's me, and then Jenna. So when we will split this image, maybe that Taylor Swift, all of the images of Taylor Swift will be in the test split. So that's a problem. Then model will not train on the images of Taylor Swift, and it will work very poor on the test set. So before doing this one, as you can see, we should use labeling from sklearn.model selection, import label encoding. Right? No, from sklearn preprocessing. I make mistake. Preprocessing, import label encoding, label encoder. So encoder equal to label encoder, encoder.fit y, encoder.fit and transform y. Here it will should do that thing. So here it is. So our y now is numerical. So we will give it, so we will shuffle it. So good, now it's good. So we'll split it. Now we will import CVM from sklearn.cvm, import CVC, and then we will create a model. So model equal to CVC, and then kernel is linear, and then probability is true. Let's set it true, and then we will feed the model the x train, then y train. Here it is, and we will predict y Brad's train. So model dot predict. So we will predict based on x train first, and then y press test model.predict based on x test. We done. So from sklearn.metrics, we will import accuracy. Then we will compare accuracy. So accuracy score, we will give first y true, so it is y train, and then we will give y press train. Let's see accuracy. So 100% accuracy, very good. It works perfectly. So FaceNet is working very good, absolutely good. So score y test. Here we will put y test, and we will put y press test. Let's see here how it's working actually here. Accuracy score. Here is also it's working. It's showing 100% accuracy. So now we are using here three models. First model is our in first model we are using this MTCNN, and as a second model we are using FaceNet, and as a third model, the simple model to classify, we are using SVM. So now let's put custom image. So let's try. Let me to put my image. So here's maybe first image, right? No, it's in test. Okay, it's in train set. I will import from here. Drive, my drive, face recognition. Here's my image. Copy paste. So t image will be cv.imageRead. So we will read that image. Then t image will be cv.cvt color t image, and then we will give cv.color bgr to RGB. So it will give the it will return the RGB image, and then we will give this image to our detector detect faces the image. Here will be we will receive x y with height. We will only use box output. Let's see. Yes, it's training, so it's done. So t image. Now we will take only the face. So t im will be the y to y plus height, and then x to x plus width. And then we will resize it. cv dot resize t image, and we will resize it to 160 to 160. And we will give this to function get embedding. So t in. So from here we will receive the test image. So let's see if it's working or not. Okay. Okay, simple mistake. It's done. So let's check test image shape just in case. So we should add one more dimension here. So just simple, we will do simple thing. Test image dot shape. Okay, test image. Okay, now it's two-dimensional array. Yes, I think yes. It's better to have this thing. Get embedding. Then we will put this thing into the model. So y preds will be model dot predict the test image. Okay, what's saying? So found the dimension 4, expected dimension 1. Okay. I run it 2 times because of that. Okay, it's having trouble. I made the same thing. So let's run again for this cell. So it's happening. That kind of problem happens. So we train it. So if I will run it, it will say error because we need two-dimensional array. So we will use test image will be test image. Now it's done. Here's y preds. So here's the array 2. What is array 2 means? So we will use that what we use as a encoder. So encoder equal to inverse transfer. We will give y preds, and it will return output. So here it is. It's showing me Sabo. So simply, this tutorial is finishing, it's ending up. So thank you very much for watching. So you can try by collecting your own data sets and training on doing the same concepts in your environment, and it's not too much difficult, and everyone can do it. Just follow these steps, and that's all. In part 2 video, we will talk about doing the same thing, the same automations, the same taking images from video, from real time, and from real videos, and transferring and predicting the human, predicting the person. So here, what is disadvantage? What is the problem here? In this code, the big issue is that our MTCNN model works very slow, very slow. It takes a lot of time. And this is not good solution for real time, because in real time, code should work very fast. At the same time, maybe 1 second delay is okay, but This MTCNN model works slow. We will replace it with another model. So anyway, so FaceNet is good, very good, well designed, well structured model. So thank you for watching. I hope you enjoyed this video. If you like it, just press the thumb up, and don't forget to subscribe and share, and write in comments how do you like the videos and this video, and what do you want to recommend to me to improve the videos. So guys, bye.